As always, our recordings of our virtual meetups will be available on YouTube about a week after the meetup, and we'll post a message on Meetup when the recording is ready. Next, I am very pleased to introduce our speaker today, Eduardo Blancas Reyes. Eduardo is interested in developing tools to deliver reliable data products. Towards that end, he created Ploomber. Hopefully he'll correct me on that pronunciation if it's not right.
That's right.
An open source Python library to compose production-ready data workflows. Eduardo holds an MS in data science from Columbia University, where he took part in computational neuroscience research. Eduardo started his data science career in 2015 at the Center for Data Science and Public Policy at the University of Chicago. Today, our speaker is taking questions throughout the talk, so feel free to put them in the chat, and I'll interrupt and ask as they come in. We'll also have some time for Q&A at the end. Eduardo, take it away.
Thanks. Thanks, Rebecca, for the introduction, and thanks everyone who is here to watch my presentation. I really appreciate that you take the time. Okay, let me start by sharing my screen. Okay, so I'm gonna show a few slides. I don't want to take too much time showing slides. The interesting part, the fun part is gonna be the demo for the tool that I'm going to be presenting. But I want to show a few things about the tool that I'm developing, so we kind of have some context and background of why I started working on this project. So my name is Eduardo Blancas, and I've been working on this project called Ploomber. And the name of the presentation is developing maintainable data pipelines with Jupyter and Ploomber. Before we start with the slides, I want to show a few things. So first, this project is open source. You can find the project on GitHub. Please, if you like the project, support us with a star on GitHub. Only takes a few seconds, and it helps us reach more people, help more people discover the project, and they can start using it and benefit from it. Also, if you decide to use Ploomber, we also have a Slack workspace. You can find the link here. So we have that space for people to ask questions, request features, and chat with other people who like Jupyter and like building pipelines. So it's a really nice place to reach out to the community and just to chat. If you want to say hi, you can find me there. Finally, we published a few weeks ago a guest blog post on the official Jupyter blog. So if you want to have a summary of what I'm going to present today, you have it here. So just go to blogjupyter.org, and then it's going to be one of the latest entries in the blog. So you can find the summary here. Okay, that's it for the introduction. Now, let's give some context for this project. Why I started working on this. Some of the things that I've seen recurrently when people work with Jupyter is that they open a notebook and then they start coding an internal analysis, like everything from getting some data, cleaning some data. If they are doing machine learning, they train a model, they evaluate the model, they make predictions, everything in a single file. Now that creates a lot of issues. First thing is, if you have all your analysis in a single file, it's kind of hard to understand what's going on. There aren't clear boundaries between the code that loads some data, the code that cleans the data. And also, if you're using Git, which is highly recommended for any kind of programming project, it's hard to use and follow best practices that software developers use, for example, doing pull requests or all the workflow that software engineers use to build their projects. Just to give an example of these kinds of things, if you push a Jupyter notebook to GitHub and then you make a small change and you take a look at the difference between the initial file and the file with the changes, you're going to see something like this. And this is a notebook that I changed, and the only thing I did was to add a new cell. So a new cell with a comment, and you cannot understand this thing, right? It's kind of hard to understand what's going on. And for developing software, it's really important to do version control and be able to take a look at the previous version, compare it with the new version, to have this in an organized way. So this is one of the first issues that you encounter when you try to work with Jupyter notebooks. Now, a second problem is that if you cannot build, or if you don't work on something that many people can work on at the same time, it becomes really complex to collaborate. Like many times before I started this project, I would work with someone, and maybe we could do we start doing some analysis. I have a notebook, that other person has a notebook, and then at some point we have to collaborate. Maybe I have to use the output from their analysis as an input to my analysis. So I just request some data and tell this person, hey, can you send me this data? I needed to do some cleaning or to create some charts or to train a model. And that person may say, okay, yeah, I'm gonna send that to you. And then I start using that file. The problem is that if we don't know where this data came from, we have a huge problem of reproducibility. Right? If we don't know how we got from the raw data to this new clean data set or transformed data set, it's really hard to make sure that we are able to reproduce our results. And it just makes collaboration so difficult because we are just exchanging files and modified files. And we don't really have a way of saying this is the raw data, and then we apply this and these transformations, and then we get to this final result. That's another big important problem. Now let's talk about the solution. And the solution that I'm going to talk about is how we think about a solution for all of these problems, and how we apply that to a framework, which is Ploomber, that allows you to solve these issues of collaboration, of using notebooks, but also using Git, and avoid these problems. So the first thing is we change the underlying format. The classic format for Jupyter notebooks is the IPyNB format, and as I mentioned before, it has some issues. So first thing we do is we use a library. We rely on a third-party library called Jupytext, which allows us to support different formats and then operate them as notebooks. So if you take a look at the left image, you're going to see that I have a .py file, and I'm opening it in Jupyter. And I can open the same file in VS Code, and it's just a Python script. It's just like plain Python script, and I'm not going to encounter any of the issues that I would have with the other format. So you can also use IPyNB files with Ploomber, but using .py files makes it much simpler to manage. So that's the first thing, using scripts as notebooks. And I'm going to show in the demo, this is going to become clear. Now, next thing, I mentioned that sometimes, or most of the time, we start a notebook and then we code an internal analysis on it, and it just becomes really hard to manage it. And especially if we are doing some large project, we have more than one person working on it, or more than one data set, it becomes really hard to manage. What Ploomber allows us is to break down that analysis into multiple small parts in a really simple way. So it almost feels like we are working on a single notebook, except we are dealing with multiple files. Now, the benefit is that we can specify clear boundaries in our analysis. We may say, we are going to use the first file to load some data set. Now, then we are going to have a second file to load another data set. And these two files never interact with each other because they shouldn't. They are dealing with different things, different data sets. And we apply the same reasoning for other operations that other things that we do to the data. So we may clean it, clean the data, and we have a script for cleaning data set A, cleaning data set B. And this is sample machine learning pipelines. So let's say we generate some features. Same thing. So these are completely independent until the final step, which is training a model. And then at that point, we merge everything that we have done before, and then we train a model. Right? But previously, all this remains independent, which means someone may go inside this file and modify it, and I might be working on a different file, and we are not going to get into each other's ways because we are working on different files. And there are like clear boundaries and also clear responsibilities, right? If we are saying this file is going to clean dataset A, then we expect the output of this to be a clean dataset. So we can kind of set those kinds of expectations about what each part of the analysis is supposed to do. Now, as a consequence of having this modularized code, we get also other benefits. And this is also another feature that I'm going to show, which are incremental builds. Let's say that we are working on this pipeline and I train a model, right? So I run everything and then this script trains a model. Now I find some issue in one of the features, so I fix it. In features_a, I fix that problem and change the code, and now I run everything again. Since I didn't modify most of my pipeline, it's wasteful to run everything from scratch. So what Ploomber allows us is to just run the things that have changed. So in this case, if I modify features A, it's only going to run features A and then train the model again. What this allows us is to experiment much faster, which is really important when we are working with data. If we start cleaning some data, we are not going to get it right on the first attempt, right? We are going to find some other issues. So really working with data is an iterative process. Like we do something and then we find some issue, we go back, apply some new transformations and repeat that. So Ploomber allows us to iterate much faster because we don't have to repeat redundant computations. Another important thing is testing. So this is something that doesn't happen often in data science. And I think we should test more because it helps us build more robust projects. So just to give an example, I mentioned before that if we modularize our work, we have clear boundaries and clear responsibilities about each part of our analysis. So if we say that some script or some notebook cleans some data, we can test that. Like if we have a definition of what clean data means for some specific use case, might be we shouldn't have values for this column outside the 0 to 100 range, for example. We can define those rules, and then Ploomber allows us to embed tests, data quality tests. So we make sure that every time we run this script, we test the output. And if it doesn't fulfill our expectations in terms of data quality, then we can stop execution and say, hey, you should take a look at this because there's something going on here. So making sure we are putting high quality data into our pipeline is really important. And if we are able to automate this process, that saves us a lot of time. Otherwise, if we don't test the quality of our data, we are gonna make a lot of mistakes. And those mistakes can be really expensive if we, for example, realize that we are training a model and we deploy the model to production with low quality data. And finally, what this allows us, like all these things that I've explained before, allows us to have a robust solution for reproducibility and collaboration. Like someone can start working on Jupyter, someone may prefer VS Code, and they can both collaborate in the same project, in the same pipeline, modifying things at the same time, sharing things on GitHub, and streamlining this process. Okay, so that's it for the explanation. Now let's go to the interesting part, which is the demo. So here I'm gonna be running everything on Jupyter, but just so you know, you can also use any other text editor. But I know a lot of people like Jupyter, and I like Jupyter a lot, so I'm gonna be focusing on the Jupyter integration. So let's imagine we are about to start, and also I'm gonna be making some small stops in each of the parts of the explanation. So if someone has a question, you can just ask it, and also feel free to interrupt me if anything isn't clear, and I can answer your questions. Okay, so now let's say we are going to be starting a new project. So first thing is we execute this command, Ploomber scaffold, and I'm going to be passing this argument empty. By default, Ploomber creates a sample pipeline, and in this case, we want to start from scratch. So I'm going to execute that. I'm going to call this empty. So this is going to create a new folder. You can see the new folder here. And for now, let's only focus on the pipeline YAML file. The other files are optional. Let's focus here. This is the central file in Ploomber. It's a pipeline YAML file where we specify each of the tasks in our pipeline. So that would be each of these boxes, one script per box. And now let's say we are going to work in a really simple pipeline. We are going to have 3 tasks. One that's going to load some data okay, let's just fix the indentation. Okay, so let's say we are going to work in a really simple pipeline, only 3 tasks. And the first thing is we want to load some data. So I'm going to say, first thing I have to specify is what is the source code that I want to use. So let's say I want to load, and I don't have the scripts right now. I'm going to ask Ploomber to create the basic structure for me. So I'm going to say, go to the scripts folder and use the get.py file. Now, what's going to be the output of that script? This is going to have 2 outputs. So first one is going to be a notebook. Now, this might be surprising, right? Why do we have a source code that's a .py file and then an output that's a Jupyter notebook? The reason is that Ploomber executes .py files as notebooks, and this could also be a Jupyter notebook, but it always creates a copy of the input file. The reason is that we may have some tables or some charts in our source code that we may want to take a look at later. So when we run the pipeline, we're going to run the script and then have an output Jupyter notebook, and then we can take a look at the charts. And we can also change the format. For example, we can do something like PDF or HTML. So what's going to happen is Ploomber is going to take this, run it as a notebook, and then change the format. So that's the idea. Let's keep it as a notebook. Now, if this script loads some raw data, we also want that to be an output. So let's create another output. So we just say data, and let's say products, and then raw CSV. So what we have done so far is we specify the first task. This is the input script, and these are the outputs. We just repeat the same operation for all the other tasks. So let's say the second one is going to clean some data. So let's do clean. So also change the name here, and this might be clean.csv. Right. And finally, let's say we want to plot the data. So this script is only going to generate the Jupyter notebook as an output, but doesn't need to generate any data. So we remove that, and we just have this here. So this is the basic structure of our project. And now I'm going to ask Ploomber to create the basic files for me. So I move to the empty folder that has my pipeline YAML file. And now I execute Ploomber scaffold again. This time, since I already have a pipeline YAML file, it's going to create those files for me. So it's saying adding scripts get, scripts clean, and scripts plot. So now, here I'm going to show this thing that I explained in the slides about using scripts as notebooks. So if I double click on this get.py, you're going to see that it's just a .py file with a few extra things. The details aren't important. So I'm just going to close this. And here's where the magic happens. If I do right click, open with notebook. Let me see what happened. Oh, OK. I see what happened. So I have repeated files. Yeah, so I should name my files in a different way. So this should be plot.ipynb. OK. Now let's do that again. Open with notebook. All right. So we have a .py script that looks like a notebook, and we can interact with it as a notebook. And we can do the same thing with the other 2 files. Now let me show you how the pipeline looks like. So I'm going to run Ploomber plot to show you that Ploomber recognizes this as a pipeline. So we now have we have this pipeline.png file. We see these 3 tasks. It looks a bit strange, right? Because it doesn't have any structure. So that's what we are going to do now. We say that we are going to get some data, then we are going to clean it, and then we are going to generate some charts. So this should go first, this should go second, and finally we should plot some data. So that's what we are going to do. How do we do that? All right, let's go to the clean.py file, then open it as a notebook. Now, this variable called upstream has a special meaning, because this is where we specify which tasks should come before this one. So if this clean.py script is loading some data, let's use what's the name of get.py. Okay, so I'm gonna do upstream equals a list of a single element. The element is called get. That means execute get before you execute clean. Now let's do the same thing with plot. So same thing, a list with a single element. In this case, is going to be clean. So clean the data before you create the plot. Now let's go and create Ploomber plot, execute Ploomber plot again, and see how it looks like now. All right, now this makes more sense. We get some data, we clean the data, and we plot the data. Okay. One important thing is, imagine that you are working, like you already have the code that gets the data. And now you are going to be working on cleaning the data. If you are going to be using the raw data as an input, it would make sense for you to have that information, right? Where is my get.py script saving the output? Well, here we have all the information that we need. So what we do is, once we modify the upstream variable that specifies the order, we can do file and then reload. And you're going to see that we have this new information. So we didn't code this cell. This cell is automatically injected by Ploomber, and it has all the information that we need to start coding our analysis. The first part is, you told me you are going to be using the get.py script as an input. So here's the output of that script. And we have the path to the CSV file, and then we can load it. And the second thing is, in the pipeline YAML file, we say that we are going to be creating an output CSV file. So we also have that information here. And then we can simply use these variables to load the data, clean it, and then save it. So this allows us to have clean code that doesn't have any hard-coded paths. And if we modify anything here, then we're going to see the changes here. So that's a basic idea. Like right now, in just a few minutes, I explain how the basic workflow looks like. You have some pipeline YAML file, you specify how many files, how many tasks you have, then you go and modify the files and specify the dependencies. And then you fill the gaps, which would be the actual coding, cleaning data, creating some charts. So now let me show a different example, because this doesn't have anything. This pipeline doesn't have anything, any kind of data, or isn't doing anything interesting. So what I have now is another pipeline, also a basic pipeline that has some code, some really simple machine learning pipeline that gets some data, generates some features, and trains a model. Now the idea is that you see how it would look like, how the experience would look like once you have a first pass of your analysis. So same thing, we have a pipeline YAML file, but this time we have a mix of functions. These are functions and scripts, and you can mix functions with scripts or functions with notebooks, whatever is easier for you and whatever you feel the most comfortable with. Let me show you how the plot looks like for this pipeline, and then we are going to dive into the details of this. So let me show you this. Okay, so this is a really simple pipeline. We get some data. Then I'm using the iris dataset. So I'm sure you have used this dataset before for some tutorials or examples. We get some data. We generate some features. One here, one here. Then we join everything into a single file, a single data frame, and then we train a model. So it was really easy for me to explain to you the pipeline because we have this graphical representation. And this is really useful when you're working with someone else. And I use this for all my projects at work. And if I have to onboard someone else to a project, I simply show this, and we can go back and forth with questions. So I explain, I provide a high level explanation of what the pipeline is doing, and then we can just have this like quick conversation about what's inside. So it becomes kind of a white box instead of having all the details inside the notebook and not being able to explain what am I doing. I'm able to do this kind of explanation. So now Let's run this. Let's see how this looks like in practice. So how would I run this pipeline? I simply have to do Ploomber build. And now I'm going to orchestrate execution, which means I'm going to get the data, generate the features, and then train a model. That's what's happening here. You see it's building the features, and then it's going to execute the script that trains the model. And that's it. So to show you how this output notebook looks like, let's go to scripts feed.py, which is the script that trains a model. Really simple. The details aren't important. I'm just training a model and then printing a report with some metrics. So this is my source code. This is the file that I modify and that I can make changes to. But when I orchestrate my pipeline, I have an output notebook, which can help me, which is like a report, right? In this case, it's a model report, model evaluation report, but this can be anything. So we go to products, report here, and you see this is the executed version of my .py file, and you can see my metrics here. And if I had any other plot, I could be able to see that here as well. And now let's show you the incremental builds feature. So let's imagine we already have a first model, and we want to create a new feature, for example. So we go to features. Actually, no. Let's modify the feed.py file. Let's go to scripts, open as a notebook, and say, you know what? I want to make some modifications to my training code because I don't know, just for the sake of an example, I'm just gonna do 1 + 1. In a real scenario, this could be maybe adding a chart or changing some of the settings for your model. And we modify the feed.py file. Let's see what happens if we run Ploomber build again. Let's remember how this pipeline looks like. So I only modified fit. I kept all the other scripts, functions the same. So let's see what happens. We are going to see the incremental builds feature in action. So you can see here that I only executed, well, Ploomber only executed the feed.py script, and it skipped the other tasks because it doesn't have to. I didn't change anything. So what's the point of running this again? And that's it. There are many other things. So this gives you a quick overview of how the experience looks like, from starting from scratch and then building step by step a pipeline. And once you have your pipeline working, how can you iterate on your pipeline? You may modify some of your existing tasks and rerun your pipeline. You may want to add some new tasks. And that's how the workflow looks like. Now, there are many things that I skip to keep the presentation short, but I can briefly mention some of the important things that that you can do. So I mentioned in the slides that you can test the pipeline. So we could do something like, let's say we want to test the quality of our training set. We could do something. We do an unfinished section, and then do tests.test my dataset, and then we create a tests.py file, create a test my dataset function, and then we can create some testing code there. And every time Ploomber runs this function or a script, can be a script as well, it's going to run that function. So it makes sure that every time you run a task, you are testing it. And then we have some other things. We can also run these things in the cloud. So if you are working with big data and your laptop or the server that you are using isn't enough, you can export this pipeline and run it in the cloud. And you can run it in AWS batch, in Kubernetes using Argo workflows and Airflow. So that's another important feature, that you may be working locally, and then at some point you may want to scale your analysis and you don't have to modify anything. Like if it's a notebook, you can run the notebook at scale. If it's a function, you can run it in Kubernetes without changing anything in your code except adding a few extra configuration. So that's it. If you want to know more, please, you can join the community. You can ask me questions. And we also have documentation. You can find the link to the documentation in the GitHub repo. And you can find lots of tutorials to learn many things, some of the things that I didn't explain here. So that's it. I think we can open the room for questions now.
Great, thank you so much, Eduardo. We already have one question in the chat from Ariel. This is great, Eduardo. Can tasks be executed in parallel?
Yes, that's a great question. All you have to do is executor parallel. That's it. So that depends on the structure of your pipeline. In this case, we have these two tasks are independent, so you can, Ploomber is going to run them in parallel. And if you run this in the cloud, each task runs in a separate container. So that's also going to be executed in parallel. So I see a second question. How is this different from ELIDA? That's a great question. I talked recently, a few months ago, to the ELIDA's team. Great guys. I think there are a lot of things in common, certainly, especially because both of them are have this notion of building pipelines from Jupyter. So I would say, like, from the surface, they are really similar, but the details are different. I think ELIDA's team is putting a lot of work into the different ways for orchestration, so you can run things in, I think, Argo workflows as well, and some other platforms that we don't support currently. Whereas Ploomber is, I would say, we are putting more effort in, like, streamlining the local experience. Like, we want people to be able to run, set up things quickly, and then start running things. I wouldn't say our priority is to support, like, many platforms in the cloud, at least not right now. That's one difference, one of the differences. What else? Another thing is that we also support functions. I am not sure if ELIDA supports functions as tasks and SQL scripts. So I didn't show that, but we could have a SQL script as a task. And I have an entry on Ploomber's blog. Actually, I think that's important to mention. If you go to the GitHub's repo and then click here, you're going to find a survey I did here. And then I compare Ploomber to many other tools, so you can see the differences between them.
Great. I have a question. It's clear to me that this is a really useful tool to use during EDA as a data scientist. And you're saying you can also run Ploomber in the cloud. So, you know, like a typical data science workflow, you know, you'll do EDA and then, like, feature cleaning and then model building and then deployment. Maybe you'll iterate on these things, but is there a specific part of this workflow that you think Ploomber is better for, or is it meant to be like the whole data science workflow? You can use it.
That's a good point. I think many projects that work with data are really similar, because you are building something like this, right? Some kind of pipeline and has certain order of execution. So as long as you can specify your workflow in something like this, it works. Now, we are working and we have some specialized features for machine learning. And I didn't mention this, but for example, when you are doing some machine learning, you may want to train multiple models at the same time. And the only difference between one model or one script and the other is that maybe the first one is training a random forest and the second one is training a neural network. And we have some features that allow you to quickly create an array or a grid of tasks without having to declare one task and then the other and then the other. So you specify the script that you want to use and then all the parameters, and then you can quickly create like a larger pipeline. But apart from that, I would say anything that you can specify as a pipeline, as a set of tasks that have certain order, you can use it, because Ploomber is agnostic to what's inside the script. As long as you have inputs and outputs, what happens inside the script is up to you. It can be cleaning data or feature engineering or creating some report, for example.
Great, thanks.
Mm-hmm.
Any other questions? Feel free to put them in the chat, or I think anybody can also unmute themselves. Ariel says, this has been great. Good job.
Thank you. Yeah, feel free to reach out to me, join the community, or reach out to me on Twitter if you have questions. And hopefully you can give it a try and use it for your next project.
Well, that's really interesting, Eduardo. I'm just curious, is this something like, is Ploomber born out of your hobby, or are you full-time on this?
It started as a pet project, actually, 2 years ago. I was just dedicating a few hours every week to build this, and I decided to open source it. And then people started using it, which I think was really nice. And for the last 6 months, I would say, I started putting more effort into building a community, because we have companies using this in production already, which is, I mean, when they talked to me and they told me we are using this in production, we have a few questions, I was like really excited. And now I'm trying to build the community and help the teams that are using it, and the users are building things like really different things. People are using it for research, people in industry, for deploying machine learning models. So it's growing, and that's exciting.
Wow, yeah. Truly amazing.
Yeah, and I think it's one of the reasons is that there aren't many tools that allow you to build production-ready pipelines in Jupyter. And I think that should change. And many times when I speak to teams from different companies, they tell me, you shouldn't use notebooks in production because it's a complete mess. And I know it's a complete mess, but that doesn't mean it has to be that way. And I really like Jupyter, and I feel like it allows me to quickly build things, like explore my data, create features, train models. And what Ploomber gives you is that extra ability to move from your prototype to production without having to rework everything from scratch, which many teams did before they started using Ploomber. They would go and create some notebooks, and then once they had a model or a prototype, they would completely refactor and turn the notebook into Python modules and then take it to production. The problem is that the moment you start breaking things down and refactoring, it's really hard to build the same thing again. So they may not be able to reproduce results. The model may not have the same performance. So it's really risky to do these things like refactoring everything just because you don't want to use Jupyter.
Right. So a lot of people start with notebooks instead of Python scripts. And with Ploomber, does it mean that you always have to maybe convert your notebook as an input Python file first, so that the pipeline would run? Or can the input be directly just Jupyter notebooks?
That's a great question. You can, so let me, so here, right, I have a Python script. I may change this to IPyNB, and it works the same. The reason why we recommend using .py files is because it makes it easier to work with Git. But if you prefer the IPyNB format, you can do that. And then at some point, you can, if you want, you can convert the IPyNB to .py. So it allows you to make that decision and then convert from one format to the other if you have some reason to do it. But you can have the pipeline be composed of IPyNB files. It's fine.
Yeah, that's great. And you mentioned that it could be SQL script as input. Maybe in the future it could be other programming language
Yeah.
files. Yeah.
So right now we also support R. So this could be, instead of .py, could be .r. That works as well. Then for SQL, I can actually show an example really quick. So we have a projects repo and have lots of examples here. I think this one is the simplest one. So this one is a SQL pipeline that, let me go to the pipeline example for me. Okay, this has a little bit extra configuration, but let's ignore the first part for now. It's not important. So you can see here that I have some SQL scripts. So I'm filtering some table, then grouping the table. So this is sales and this is prices. And then I join everything and then I dump the table into a CSV file here. And then I use a .py file to generate a chart. So instead of having a single file that manages the connection to the database and then apply some SQL queries and then downloading the data, Ploomber allows me to write SQL scripts. So I can show how this looks like. So a SQL script with some extra placeholders that we need to execute the pipeline, but it's simple SQL. And then in the pipeline YAML file, we have a task that dumps the output of the table in a CSV file, and then we load that CSV file into Jupyter. So we only write SQL files and .py files and not worry about managing connections to the database, and we get all the other benefits like running things in parallel.
Yeah. So suppose you want to run something. Is there like a way to specify the software that right in this configuration file?
For the database?
Doesn't have to be database. Maybe, I also use, MATLAB or other software somewhere in the pipeline.
No, fortunately, we only support Python and R for now. So this has to be a SQL file, a Python file, an R file, or a notebook in Python or R.
Got it. Okay.
Yeah.
Really nice.
Any other questions? Great. Well, thank you so much, Eduardo. We don't get a lot of demos actually, so this has been really nice.
Great. Thanks everyone for being here. And if you have any other questions, please reach out to me and I can help you get started.
Well, thanks again. Live demos are really challenging. You have done it perfectly.
Thank you.
And thanks, Rebecca.
Yep.
You're a perfect host as well. Okay. Bye.
Bye, everyone.
Bye.